pleasure to invite Professor Atlas Wang from ECE at UT to give a talk on his most recent study on facial recognition and video processing. So we will get started. So Professor Wang, the floor is yours. You can start to present.
Sure. Thank you, Jingfeng, and thanks everyone. And so the first thing I'd like to get clarified is this is not at all a latest work. So this is actually a collaboration project we did with Adobe and other parties almost more than 3 years ago. But now we are reviving on this topic because we participate in Good System and work with Sharon and other PIs extending this study from the smart home scenario to smart city scenario. So today I'm just trying to give you a wrap up about what happens in this flow and what we did before. So should I get it started, Jingfeng? Oh yeah, thank you. Right, so I'm by education a computer vision person, and I guess everybody knows that computer vision is being deployed in all kinds of devices and platforms in our daily life, from a mobile phone to the smart home devices to the smart city surveillance at different scales from individuals to population. And one of the interesting applications, and perhaps one of the most profitable ones in applying computer vision, is the smart home devices. So I put several news. I put several screenshots of news headlines here, and they actually come from a few years ago. As you can see, I prepared this slide actually came from a talk I gave almost 3-4 years ago, and by that time, 2017, 2018, there was a business momentum to put computer vision in smart home devices, including the launch of Amazon Echo Look, which I believe many of you have seen this before. Installed a camera in your smart home, and that camera could recognize your pose, recognize your body information, so you could use very diverse ways of human body language and pose, like a gesture, pose language, to interact with that camera. Besides, that camera could also do many biometric and recognition functions for your home safety and for your health monitoring. So it's very powerful. But after that device has been launched, it actually immediately received a lot of dispute from the market. And there were several major headlines. I remember a New York Times headline too, saying that, customers are very hesitant to buy this device because this device will recognize your video, recognize your interactive video at home and upload that video for Amazon backend cloud to analyze. That was a bit concerning, primarily because those computer vision functions need a very sophisticated machine learning analytics, and the resource cost of such sophisticated functions were not very affordable by the edge device, so they need to transmit back to the cloud. And then people get concerned. Why should I upload my video data back to the cloud? And especially those videos are captured from my home, right? We can do a lot of private things at home, and who knows what I did was captured by that video camera and being shared with Amazon, and what may be leaked. And then the story actually get a bit funny. I remember Amazon's spokesman issued a response saying that customers shouldn't be worried because Amazon has the best security protocol in the world. So your video device, your video data get uploaded to AWS will not be hacked or reshared by any third party. And that actually become funny, and the customer respond with an even bigger angle. Who said about the third party? I'm worried about you. I'm not worried about any third party. So that actually become a very interesting public discussion. And I could give many more examples similar to that. Amazon Echo Look was just one of the examples. I'm not taking any attitude towards the device. I'm just telling you that as those devices with the computer vision functions being launched and being popularized into humans' daily life, it will inevitably have a debate with how much we should let them go deep into our private life, and also how to define privacy. So those are all become open questions, and those are being discussed more and more in recent years of computer vision literature. So the dilemma here, the difficult situation, we have to make a choice, is also very clear. We humans are lazy people. We would always love a computer vision or all the general sense of AI to help us do the repeatable things, recognize an important event, and provide all kinds of assistant functions to our daily life. So that all involves cameras, just like a human, watch our life by the side. But I think we just don't have that right law and ethics to regularize what a camera should think and what a camera should not think. But now, if you ask a public or ask any citizen, I guess the first reaction you will get would be predominantly, I don't want a camera to look at me, because it may obtain too sensitive visual information that could intrude my daily privacy life, as we mentioned. But in the meanwhile, if you ask people, do you want that convenience that the cameras bring to your life? Everybody will answer yes. So that's actually a contradictory problem and leave computer vision people a big question mark how much we could do. And I'd also like to know that there are many respectable researchers working on the security and crypto side of for securing data, including video data. But those solutions are not directly applicable towards solving those new privacy issues because they essentially target different goals. Well, what traditional computer security and safety solution target at are the unauthorized access to unauthorized people, the hackers, the attackers. So they may airdrop your data. They may get unauthorized access. So we want to protect against them. And that's what Amazon spokesman was talking about. We have very mature techniques to defend against such kind of unauthorized hackers. But now, as we are sharing more and more data with the authorized party, like Amazon, you have purchased the device. It's equivalent to you have agreeing it into your life and you put it there, open that camera, nobody forced you to do that. But you have no full idea how much it will intrude your privacy, and you want to regularize their use of your video data. Even you have authorized them to watch you, you want them to be further regularized about what you watch, what they watch, and you don't want them to abuse the video data you observed. So here is a big gray area in computer vision side privacy, and that fails almost all existing crypto and computer security solutions. So I'll briefly review what this field has been doing on that. There are primarily very ad hoc solutions. And if you search, you will be able to search a few commercial product already implementing that on a hardware prototype of cameras. For example, someone has proposed that, well, if we could build a very powerful camera as a front end, so like if assume one day Amazon Echo Look will have as rich computation power as your backend server, it could do all the computer vision functions by the end and no need to share any data with backend. If we're doing that, isn't the privacy issue being resolved? Well, yes and no. It will be better, but I will remind 2 points. Number one, it has been revealed and actually proven by several computer vision papers that even I only extract feature descriptors such as human pose, human gesture, like I do those recognition all by the end and only transmit those features to the cloud. Then it may still leak human privacy information. There are ways called reverse engineering that can reconstruct unintended private information from the shared public data. So I can tell you, it's still not absolutely safe. And the second thing is, there are many cases that you often need to share more and you share more to the cloud because many of the functions you would like to have is not only built on your own data, it's based on data in the same network of users. It's like, for example, when you come to Netflix, you get recommended with movies, not only because you have watched similar before, but also similar users in your same network has watched and liked them, so you may also like them. That same idea, called collaborative filtering and recommendation, would also be used in many computer vision-based functions. You will need to share more data to the cloud, so the cloud could summarize similar patterns in big data from the other user network and to better characterize your pattern. So short message from this is to transmit little to no features to the cloud is neither absolutely safe nor always useful. So it's not a perfect solution. Crypto solutions, we already said, is not applicable, and the crypto solutions like adding like encrypting data is often as expensive as computer vision at the front end. And the more practical and widely applied ad hoc solution in the real life is actually what? It's actually surprisingly simple. Mailing cameras to avoid to avoid video leak too much information. We'll just very aggressively downsample the video before share with the cloud. Here means originally you get a 1K, 4K video frame, but then I downscale the video frame resolution by 10 times, 20 times. So everything there is just barely recognizable. And I would say that, yes, this is a cheap method, but you would immediately guess the same as I would guess, this wouldn't be very friendly to the actual utility of this video, right? You are basically doing like, I'm destroying this video, so it's not sharing any private information. But if you have destroyed the video, the usefulness of this video has always also been seriously downgraded. And it's very hard to say who wins this trade-off, who get a better deal. Do you protect the privacy more, or do you destroy the utility more? And in practice, this trade-off is not always to your benefit. And similar questions has also been raised in relevant applications. For example, sharing a photo in social networks such as Facebook and TikTok. So there are also many privacy concerns there. For example, when you share a photo, you may not realize that some private sensitive information are contained. You only realize after you click the share button, and many people has already seen that. So that problem will further get socially complicated if I share, for example, if you can share a photo including a friend, but your friend do not want that photo to be shared, then you could share a photo only including yourself, but without other private sensitive information that you are not authorized to share, such as your friend's face. So this could go very complicated when social components get added. At least that's my understanding. And the current solution provided by big players like Facebook and TikTok are pretty much similar, like how we did in the video sharing system. They were just add empirical observations, like you could opt to use a blur filter to some of the human faces there. So if some human do not want to be shared, their face could opt in to be blurred. But still, the blur is only, empirically works, because just think about your life experience. If you share some photos if you share some photo by other people, if you see some photos by other people and the face get intentionally blurred, but if that person is someone you know in life, there is still a high chance you can recognize who is who, right? Because blurry is only a very empirical way to reduce the recognizability. And more recent solutions has introduced more advanced math tools, such as adversary learning, which is a form of game theory in trade-off between the two, which is some method we did before. So I do not want to go to mathematical details. I know we're just a splash talk, but I can tell you the main ideas. We formulate this so our target problem is to share video and share video in a useful form while protecting the privacy being leaked. So, but we assume we have some utility information that we know we want to gain from the video, and some privacy information that we know we want to protect from being recognized from the video. And so we formulate this as a two-player game. There is an attacker who trying to intrude that privacy information that we try to protect. And there is a defender who try to defend against the attacker, so the privacy will not be released. And meanwhile, the defender take an extra role to preserve the information that we wanted to preserve and be recognized, the utility. So they actually will play a complicated game, a non-zero game, and eventually we hope to learn. They will learn a transformation. Their computation will lead a transformation learned to be applied to the raw videos, and the transformed video will only be preserved with the target information we want it to be recognizable, but be fully removed from the private information we want it not recognizable. So the math details will involve minimax optimization. I will not go into that, but you're welcome to drop me a line if you're interested to know more about the math. But I also just one side comment about this game theory view of privacy protection versus utility preservation. This, I think you may easily come to the intuitive feeling that this definition is very vague, and the actual difficulty level of doing that to remove some privacy while preserving some utility, how difficult it would be will be fully dependent on what is the utility and what is the privacy. And you are right in that gut feeling. So depend on how tightly coupled that privacy information and utility information are in a practical setting, the actual feasibility of this game theory based view will differ a lot. I'll give you an example. So for example, let's directly look at this first visual example. This is a pose estimation dataset, and our goal is to recognize the human pose. Are they standing? Are they walking? Are they shaking hands with each other? But in the meanwhile, we do not want the video to contain information that can identify who is that person in that video and whether it's a female or male. We do not want those identity or demographic features to be identified. So if I'm asking you, I want to transform the video in a way so the human body pose information can be preserved, while the human identity information to be preserved will be discarded, so it cannot be recognized or leaked. What you could think of as a plausible solution immediately. Okay, so I will show you the solution found by our game theory framework. This is the transformation we learned. From the raw videos, so this is all automated learned from data, no handcrafting, it's by machine learning method. And but the filter we have learned try to only pick up the human body parts and the joints from the human. And it forms the human in a shape like a skeleton, like a bone skeleton of the human body, while I have depriving all the human body shape, human face, and of course, skin color information from the video frame. So after this learned transformation by game theory, we get nothing but a two skeleton persons. And from the two skeletons, you can still barely see, and you can still barely tell from your human ear, like these two people are like looks like they are shaking hands. Those two people looks like they are hugging. Although you didn't see the real natural image, you cannot get a feeling by just looking at those two sketch, right? And I can tell you machine learning models can predict from those transformed images about their action as accurately as they were directly predicting on the raw images. So the utility get preserved, and apparently the privacy information like human identity and the skin color like that all get freed up from this transformed photo. So I'll just show you some more complicated transformation we learned. Like those are our game theory learned filters applied on real YouTube videos. Again, we try to protect the human action in the video sequence while defending against human skin color, human gender, human identity, and also some other privacy defined privacy attributes such as home address, such as like in some videos there are nudity and some intimate relationship in the video sequences. So we have defined all those as a privacy we want to deprive. And if you, in our learned filter, if you fit in raw video frames like the leftmost column, you will get the rightmost columns as the output. While you see it seems tries very hard to distort the human body and the human face, while you can still see some indicator of performing the original action, such as applying lip stickers, such as doing home exercise, but it has become very irrecognizable. And we have further that direction by providing the first smart home video privacy benchmark, where you could access from this link. And we have annotated in large scale YouTube videos about YouTube videos. We have asked the student participant to denote where they think intrude the smart home living privacy besides their original utility to recognize actions. So for example, those two video sequences, the student has annotated, they think it leaked the skin color. Sometimes they are viewable for face. and gender, and sometimes there are nudity or partial nudity, and sometimes a relationship. So we have all those metadata annotated in thousands of video sequences downloaded from YouTube, and we have released that as a benchmark for algorithm for people to evaluate how privacy intruding their video recognition algorithm release. So, and this is perhaps the first of its kind. And in our released video benchmark, we also trained our own version of game theory-based video filters. It's not applied, if from my view, it's not perfect. So it still have some difficulty in handling complicated scenarios. For example, like this frame, I can still barely tell who is the original actor, but for many other frames, you see the algorithm's effort in balancing between action and utility. So you can see that. And I would also like to mention that, as I mentioned in the previous simple example, it's how difficult to preserve the utility while removing the privacy totally depend on how you define utility and privacy. If in the original simple example, there exists apparently easy answer to preserve only the body structure by keeping a skeleton-like thing while removing all other identifiable information. But for another example, if I give you another privacy utility setting, let's say I want you to do, I'm just saying for example, I want you to do gender classification while I want the age information to be fully protected. I would imagine this trade-off to be much harder to achieve because both are tightly coupled with the facial features. So the algorithm will see difficulty in how to balance between what a face feature to be preserved and what to be removed. So this discussion eventually will be very context dependent and heavily depend on clever definitions of privacy and utility. And my last page. So I think to further this direction of research, we very much like to work with the social science researchers to tell us what is the real privacy and utility in different contexts. And that's what one part we have been collaborating with Sharon, Maria, and our team in Good Systems. We're also working to scale up to more and new privacy and utility attributes for both sides. And we are further hoping to implement a concept we call the differential access. That is, we are not only generating one filters that would target at one specific utility and one specific group of privacy. Instead, because different people may have different authority to access different purpose, the access data for different purposes, it's perhaps worthy to have a group of filters rather than just one filter. So high authority people may be able to introduce maybe access more private data and vice versa. So that's something we are trying to implement now in our smart city-based computer vision project because in government there exists such a hierarchy. And eventually, as algorithm people will start to play with some theory guarantees for the game theory method. It's still ongoing. And if you're interested in learn details, here are two most relevant people from us. And that concludes my talk today. Thank you.
Thank you for Professor Wang's talk. And now we open for questions. Any questions from the audience? I do have a quick question. So you mentioned the how you define utility and privacy is a key. Oh, there's one question from Amin. Let me finish that. So Atlas, basically how you define utility and privacy is a major issue. So I would imagine if you, in many situations, in many cases, people want to see the facial configuration and even like so do you think there's a way to protect privacy, also guarantee the ability to recognize face or to achieve the utility with the facial recognition? Do you think that's even possible?
Well, as I said, here, if you say so, then you are considering face recognition as a utility. So you must have some other privacy you want to protect. For example, like if you say you want to recognize human face expressions, but you do not want to keep the identity information of that human. So for that specific example, I can tell you, yes, it's possible. Actually, one undergraduate student working with us already did that. It's doable. But you cannot say that I want to do face recognition, but I wanted to I want to also not do face recognition. You cannot say the utility and privacy takes as one, right? That's not a science anymore. But yeah, again, I cannot say anything about a guarantee. So any guarantee here to us means a proof, and I don't have a proof. So and but I could in I would say that here maybe we can use our common sense to think of if you were human and you were to craft a way that to achieve that trade-off. Do you have an idea? Do you have a difficulty sense how difficult it would be? Like I said, for example, like this, I think smart people may be able to get the same idea too. I will just recognize the joint location of the human body and connect the joint. So I get a skeleton person. Skeleton person is very privacy free. But I like say, if I like as an example, I said, if I want to recognize some human face-based detail and why I wanted to suppressing some other closely related human face-based detail, then you are like fighting yourself. It's not always possible. So eventually, as I said, it's still a context dependency, and we don't have a guarantee. We can only suit our customers' need.
Very good. I mean, you have a question about, you said the privacy attribute vary from one user to another user or from one group to another group. That at least you have any comment on that part?
That's for surely true. And actually, 2 years ago, once we conducted the project with Adobe, we were interested to make this filter more personalized. And the idea is then, because training this game theory thing is very expensive, so we do not imagine to train one for every user. What we imagined instead then was also to create a group of pre-configured filters, and a user could like try on, just think of like how you apply Instagram filters to your photo. User could try their photo, the filters one by one and choose their favorite configuration. That was a product prototype we were planning, but for various complicated reasons, it didn't continue into the production stage. But I am actually very happy that now in a different context, we were possible to revive the same idea in the Good System project in Smart City, because now it's the same. We want to generate a group of filters, but now not for personalized use, but instead for different people people in different hierarchy in government that was authorized to access a different level of information and do different things. So I guess our solution will be the same, to generate a group of filters rather than one filter. And also the privacy information is also very context dependent, even for the same person. I think that added to another level of complicacy. For example, if you are, let's say you are in, your body are in partial nudity by a sand beach, then nobody will feel any problem, at least in United States, right? But if you are in partial nudity in UT campus, I guess you will get a lot of people watching at you and no one will feel it's very appropriate I'm talking about in class hours. So it's again a very variant thing. So yes, I believe the ability for user to choose privacy preference by person and by context is the eventual goal we want to achieve here.
Just a follow-up question. All this research is based on visual recognition. So there's many things, as you know, like a voice also closely related to visual. Have you think about add another dimension? Maybe you can totally filter out or 80% cover the fake visual information, but just add 20% of voice information that are gonna achieve a better utility goal. Also,
that's a very interesting question. I'm glad you asked that. So number one, we actually have another small paper we didn't list it here that done by another previous undergraduate student, applied the same game theory idea to speech recognition, exactly the same idea. So we want to recognize what is a specific human was talking about to transcript the speech, and meanwhile removing the information about who is speaking. So we did that game theory trade-off in speech recognition, in identity protecting speech recognition as well. And we actually have a published paper on that. So that is the same durable in speech recognition. But we have not, and I don't believe anybody has done the privacy trade-off on multimodality when you both have video and audio. I don't think we have prior work, but I think I would immediately agree with you. There is a larger chance to trade off what modality to preserve more, what modality to preserve less, because yeah, it's definitely easier to see and identify people rather than hear and identify people. So I definitely see a chance for more delicate trade-off there.
Very good. So we are already at the time mark. So thank you very much for Professor Wang's presentation. So we will have our bi-weekly presentation like this on every Friday from 10 to 10:30.